Hello everyone, my name is Hany SalahEldeen, and today I'm presenting my PhD dissertation entitled Detecting, Modeling, and Predicting User Temporal Intention in Social Media. I know it's a mouthful, so bear with me, I'll break it down as we go. My advisors, Dr. Michael Nelson, my committee, Dr. Michelle Guaido, Dr. Hussein Abdulwahab, and Dr. Abdus. So, before we start, I'd like to give a little bit of context here, okay? So, we all use social media, all right? But Twitter, for example, as an example of social media venues, it's not all the tweets that have been posted by people are equal. Here, for example, Daphne is describing her delicious dinner and so on, and she's attaching an image to it. Here, Hassan, who's actually narrating something that happened during the Egyptian Revolution of 2011, where someone had been shot dead in the face by the police riot. The anti-riot police, here in Cairo, he's associating an image. There is a question here that have been triggered. These linked resources, how long would they last? And if they were disappearing, can we find a backup somewhere? And if so, what did the author intend for you here to see? For example, here Hassan, what picture did he want you to see? What state of the resource that what he intended for you to see? All right. Why do we care? All right. Everyone will thinking Twitter or tweets or something. It's just something that contemporaneous. You do it to show your kitty pictures or delicious dinner or something. But it's a little bit more than that. During the last entire millennium, the newspaper portals have been considered as the first draft of history. Now it's a little bit faster, and it's been written on a regular basis by regular people like you and I, on a regular basis during those clashes, during those events. It's not 10 years later by a historian. During this protest, Hassan was there, taking that picture, posting it and tweeting it. We don't want this first draft of history to disappear, and that's why we care. So, this is a little bit of why we are heading towards that direction. First, I'm gonna illustrate my motivation behind that. People use social media for multiple reasons, okay? For example, to convey evacuation routes, like newspapers, as fast as they are, or a news portal like CNN.com, as fast as it may be, even during disasters and special circumstances, it updates every 4 hours. A whole lot can happen within 4 hours. That's why people rely on social media in cases of floods, like in Goya in Argentina, and here during tsunami, to find escape routes for multiple reasons for them where they needed a very fast to previous portal of information that they can actually rely on. Furthermore, here I'm mentioning 3 people, 3 unknown soldiers and the thousands that have vanished. All 3 of them have died during what they did, like during clashes, doing what they have been working all their lives for. For example, here Hany SalahEldeen is a photographer, French photographer, award-winning, and he and Marie Colvin had died in 2012. They actually exploded, crossing the Syrian border, trying to cover the Syrian uprising in 2012. Ahmed Asim here, he is actually younger than I am. He got shot in the head while he's taking a picture of the sniper who killed him during the protests in Egypt in 2013. So why do we care? Because we don't want the works of these people where they lost their lives to convey this picture, this article, this blog post, and so on, and lost their lives to doing that. They died, we want to keep their stuff. You will think, okay, when you post something on Facebook or Twitter or even an article, something reliable here like Wikipedia, or fairly reliable as we think, it's going to stay there forever. Not particularly. Within less than 2 years, the official webpage of Hany SalahEldeen on Wikipedia, 3 out of the 8 external links within less than 2 years have already disappeared or became completely inaccessible. And here, this is actually a famous journal de photographie. It's actually a very reputable French website. Okay. Furthermore, articles that talk about his death have already disappeared, as we see here. Even more reliable news portals, like here NBC News, and this is an official tweet from their portal. There is a different challenge here that we face, not only here by disappearance, but rather by change. When someone clicks on, sorry, I'm going in a different direction. Here by disappearance, here by change. When you click on this link associated to this tweet, you find something completely different. Not talking about Remy and his death, but rather about the DC fiscal fail. Furthermore, even specialized websites, not news portals that where you expect it changes all the time. Here, this is the British Journal of Photography, where people were trying to commemorate his work. It already changed within, I think, less than 2 years as well. All right, we have a problem, okay? What the author intended for you to see is not what you actually read or experience when you click on a specific social post. And when I say social post in this context, I'm talking in general as Twitter, Facebook, any social media portal, all right? That leads to another problem, which is a more general one. There is inconsistency in what you see on the web in regards to time and historical records. And this is fairly important in regards to historical events and tweets about those historical events, or social posts in general. All right, let's give a little bit of background here so we can actually all grasp the problem together and build on it. So, let's dissect a social post or a tweet in this sense as an example of a social post. All of them have a textual content. Here, as a tweet body, all of them have a mention of the author who authored this specific tweet. There is a timestamp, and what we are more concerned about, a link to an external resource or a web page where more information could be conveyed. It could be in the form of a video, it could be in the form of an image, and so on. So we have three layers here. We have the context of the tweet or the textual content. Here, there is a link, and there's an external resource. So, with the social post, it has a specific URL. The resource that links to has another URL, a shortened URL within this, because Twitter have a restriction of 140 characters, so that's why you have to shorten the URL before you actually post it, because most URLs are like 90 different characters and so on. So we have three chances of failure. With this short URL, when you click on it, you perform actually an HTTP response 301 redirection, where it redirects you to the original location where this resource have been. In this case, for example, CNN.com, here, redirection towards my blog post article, all right? So, taking a life cycle of a tweet, or an author in Twitter, he posts a tweet, and he linked to an external resource, which the reader have received, if like within the 5 minutes from tweeting, mostly the reader receives the same state of the resource when he clicks upon his external link or this resource. This is ideal. But furthermore, if we wait a period of time, this could still persist. You could still, like a month later, click on that shared resource and see the exact same state that the author saw. But in some cases, this resource have disappeared, or more complicatedly, it has changed. And this is where the tricky part comes in. All right? Extensively, as we are mentioning background, we and our entire research group, we use Memento framework as a protocol for accessing archives, because we negotiate and work a lot with the public archives that take snapshots of live content on the web. To negotiate with them, we utilize the Memento framework. For further information, please refer to mementoweb.org. All right, we have enough background. We always, since this is a fairly new topic here in regards to intention, and we're trying to model temporal intention and the whole concept of intention in regards to time, we need to do a related research and see what other people, the greatest in the field, have worked around that. Since it's a very novel idea or concept, we covered a lot of related work around that specific topic in regards to understanding microblogging, different types of intention, how it differs from sentiment and mood, and so on. All right, we have a background, we have an understanding of the problem and related research that has been done in regards to this specific problem. Let's formulate the research question here, so we know where we are going. In this case, can we estimate the user's intention at the time where they are tweeting and reading and predict this temporal consistency or inconsistency in this case? All right, with this research question, we reach a certain understanding towards specific 4 goals that we are going to target with this in this dissertation. First, we want to detect what is intention in regards to time. Okay? Yes, the author reads something and he has an intention and exerts it when he posts something. The reader expects an intention to be received from the author. What is the intention between those two and how to maintain it? So we need to understand what is intention in regards to time. Furthermore, we want to model. How can we detect features and create a set of features that give us an idea how to detect this temporal intention? Furthermore, with this understanding and this modeling, building a user behavioral analysis classifier, can we predict this intention? When the author have tweeted this content, can we predict it? Finally, we propose a set of tools or a framework that could utilize this prediction in maintaining the temporal consistency of the web and enhancing the archived content and maintaining this expectation between what the author have shared and what the reader have read. All right? From here, we propose our work extensively. There are three factors in the work that we're analyzing here. We have the shared resource, we have the concept of time, and furthermore, we have the user and how to analyze his behavior. To break it down, and actually every stage of this analysis actually yielded a paper or two, where we, in our journey to find the intention, we pass through these three phases. First, in regards to the shared resource. All right, we already established that shared resources change and get deleted and become missing and so on. We want to measure how much of it is already alive. To do so, we built 6 different data sets in relation to 6 historic events. Here we have the Iranian election, 2009, H1N1 virus outbreak, Michael Jackson's death, Obama's Nobel Peace Prize, all from 2009, and all of them have been extracted from the SNAP, which is the Stanford Network dataset. SNAP, the dataset of 500 million tweets. We already have it and acquired it from Stanford. Furthermore, we create a dataset in regards to the Egyptian revolution that I have actually manually extracted those from Twitter, different websites and collections, and furthermore books in 2011. Finally, the Syrian uprising, we're using the Twitter API to extract tweets in relation to the Syrian uprising in 2012. Okay, we have 6 historical events. We want to create those data sets in regards to those events. How we do that? To do so, we know trivial hashtags. Okay, hashtag is for those who don't know Twitter, it's a way to find topics in specific tweets, so you can follow a certain trend. We know a couple of words that can act as a hashtag in regards to each of those events. Let's say H1N1 outbreak, we know H1N1. So from the dataset of 500 million tweets in 2009, we extracted all the tweets that had the hashtag H1N1. Furthermore, in order to make sure that this specific tweet talks about this specific event, like for example here, in Obama's Nobel Peace Prize award in 2009, if we only extracted tweets that have the word hashtag Obama, it could cover politics, it could cover health insurance. We don't want that. By finding the coexisting hashtags, the top co-occurring hashtags in the collection, and coexisting at the same time, so we know for every tweet that have hashtag Obama, hashtag Nobel, we know it's talking about this specific event. So we extract this data set and subsample it. Now we have 6 data sets in regards to 6 historical events, and we made sure that these tweets, and every tweet had an external resource linked in it. We know that those data sets are talking about these events. But what are they referring to? What are they sharing? We did a top domain analysis, and we found that there are a lot of people sharing stuff, for example, in regards to the Egyptian revolution, sharing YouTube videos, CloudFront audio bits, and YFrog and TwitPic pictures. All right, with this understanding, from each of these data sets, we did a HTTP response header, like a head request, and recorded. If it gave a 200 OK, means that this resource actually exists, or still on the live web, we can proceed and call it success. If not, if it's a 404 or something like this, we call it a failure. Furthermore, we used a memento aggregator to get the archived content, like to ping the archives for the archived content in each resource in this dataset. All right? Okay, these are the numbers that we extracted here, the percentages missing and percentage archived. Okay, we checked the live status or not of the resources in the data set. We noticed that there is a large percentage missing. So we wanted to pay closer attention to this, because that's where the interesting part is. So if you record here in this table, you can notice here there are two numbers for each of the events, H1N1, that have 23 and 25%. What are these numbers referring to? Actually, when we plotted for each day here, the x-axis in regards to time, this is 2012. I apologize if it's not clear, the projector is not really working well. 2012, going back to the past in 2009, for every day, in regards to each event, we collected how many tweets have been posted about the specific event at that day. If we notice a very interesting phenomenon here. If we focus on Obama's Nobel Peace Prize as an event, here featured in pink, we'll notice if we zoom in, there are two peaks. When we analyze what those two peaks map for, by checking the news timelines, we found that the first peak happened when the announcement was released. Second peak when he actually received the award in Oslo. Furthermore, if we check the H1N1 outbreak event, we found the first peak when the worldwide outbreak was announced. Second is when the vaccine had been released. Okay, this is interesting. So we extracted those percentages as we saw the percentage missing in regards to each of those peaks, plotted them against time, and we found that there is actually a relationship with time. The blue, I'm sorry, it's not really clear. The red is actually the percentage missing. The blue is for the percentage archive. We noticed that as time goes by, in the past, there is an increasing risk that resources get disappeared through time. Not so much as for the archived content, because it doesn't get archived all of a sudden after a couple of months. But as resources get older, there is a higher risk of disappearance. So we found actually a linear relationship with time, and we created this approximation here, and we found, our finding is that within the first year, 11% of whatever have been shared and tweeted on in the public web and in social media portals have already disappeared, 11%. Furthermore, after that, we lose 0.02% daily. Might not seem as significant, but think about it this way. In 8.5 to 9 years, we'll literally lose everything that have ever been posted in regards to the Egyptian revolution. And that's significant. We published this article, and this actually got a lot of media attention and got translated into about 7 different languages and was featured in the BBC. And we published these results in TPTL 2012. A year later, we did a prediction. Okay, we want to test this prediction. So a year later, we recalculated everything in regards to the 6 data sets, and we found that there is a prediction error of 4%, which is fairly acceptable, but not so much in regards to the archive content, which was 11.5%. So that gave us a pause and got us into a different phase where we needed to check the archive content, and that led a different side experiment. But before we get there, all right, we know that there is content that had disappeared as a regular function through time. All right, sorry. Okay, for this disappearing content, can we find a replacement? Or we should just like sit and cry, oh, they got disappeared. Can we find a viable replacement for it, given the context that we can extract from the social media post? Let's see. So, what we did here is we conducted a small experiment where we noticed something here. For example, here Marco have tweeted about a certain website called 18 Days in Egypt. I know, I'm sorry, I'm using a lot of Egyptian revolution related references. I'm Egyptian, I'm biased, so yeah. All right, so he's tweeting about this website. It's called 18 Days in Egypt. And he's describing it as a collective documentary project and so on. Let's assume this web page actually disappeared. What should we do? With the URL 18daysinegypt.com, if we utilize the Topsy API, Topsy is a service to extract the social media content. With it, if we extracted all the tweets that reference 18 Days in Egypt, we can get a little bit of context here. For example, Tatiana here had been talking about, in her own words, about that website, different than what Julia here had described, okay? These words have been written by humans as a description for these websites. That gives us a lot of information. Here, okay, this might seem a lot, but anyway, here there are very interesting features. For example, there are some links that co-appeared within those tweets describing this website. Here there is a Mashable article describing this documentary. If I lost 18 days in Egypt.com webpage and someone provided me with a Mashable article, that should act as a viable replacement. At least will give me an understanding what this documentary is about. All right. So, furthermore, with all the content that have been written by authors in description of this website or this URL, that's gold. That's as if we are assigning all of these written descriptions. If we accumulated them, as we did here, we accumulated all those tweets, removed all the URLs, user mentions, hashtags, and so on, and created what we call the tweet document. From this tweet document, we extract the top 5 like frequency occurrence, the top 5 terms, and we created what we call a tweet signature. What are we going to do with this signature? This signature is actually vital in rediscovery. If we plug it into one of the search engines, in this case Google, and click search, we'll find the original resource that had been missing. Furthermore, or what we assume that that is missing. Furthermore, any of these resources, or any of these URLs or web pages, can still describe that same website, can act as a replacement for it. And that's what we propose. Here, with this technique or this algorithm that we are proposing, we want to evaluate it, because we cannot just propose something without testing it. So we collected a data set of 731 resources, and we assumed that they disappeared. And we applied our algorithm and extracted from each the top 10 resources that appeared from that resulted from the tweet signature. From each one of them, we measured similarity with the one that we assumed that is missing, and see how close our replacements are. In this case, by assuming 70% similarity between the original and the replacement, as calling it as a good enough document, with 70% similarity, we found an identical replacement in 41% of the cases. So almost half of the cases we can actually find an identical replacement. If we decrease the percentage, we can still find less identical replacement, but they are still viable. That's exciting, all right. We found with these 70%, we had 41% of the cases, and a rank of 43, or 4.43. We published these results into the TPDL 2013. With this, we have analyzed everything in regards to the shared resource. What's next? The concept of time. And here I will take a little pause, because this is, in my perspective, one of the most important aspects here. The timeline of any social event or any social post that have been posted in regards to an event. The author tweets it. At one point in time, it could be 5 minutes, it could be a couple of months. You click on it. A lot of things happen within this period. And in order to understand the relationship between those two ends, we need to understand what's going on here, because this is crucial. To do so, we ask ourselves, all right, in a lot of cases, there is change. It could be minute, it could be 1%, it could be 2%. In a lot of cases, it's actually fairly significant. Like a CNN.com page, if you shared it today, tomorrow it's going to be changed by, I don't know, like 70, 80%. All right, to do so, first, we started with a pilot study with a handful of URLs that we select at random, and we manually check them and filter them out, and created a sub-data set where we checked it, downloaded the content every 10 minutes. Actually, here it's every 9 minutes. Every 10 minutes, we downloaded the content and see if it changed or not. Using rooted change, we found actually after around 80 hours, it changed significantly in some of the URLs. Okay, that's promising. Let's go further. We extracted another data set. We wanted to see, okay, do people share stuff that is new, or something that had been created a week ago, or a month ago, or a year ago? To do so, we extracted this data set of 4,000 randomly extracted URLs from Twitter API. All right. From that, we only limited them to Bitly. The reason behind this is because we can use the Bitly API to extract the creation date, and that's what we are looking for. So, extracting the creation date for all of these 4,000 Bitlys, we found that a huge majority, like 2,400 out of the 4,000, have already been created within the last day. All right, that's promising. But still, people share stuff that is a year or more old. There is a high risk here of conveying something that is not there anymore. All right. From these 4,000, okay, we knew that in this case, we knew that people share mostly new stuff. So we extracted 1,000 URLs of fresh Bitleys that have been created within the last day. And we started analyzing it vigorously. All right. First, we wanted to understand what level of in-depth that people share resources. In this case here, by depth I mean like CNN.com, that's depth 1, it's a surface page. CNN.com/Word, a little lower. CNN.com/Word, 2009 showbiz, this is actually the article announcing that Michael Jackson died. It's of level 6. This most likely won't change, but CNN.com most probably will change. A lot of people actually share very surface-based web pages. That's where the danger happens. To further analyze this, we wanted to know what domains do people use, or what domains do people share. They share a lot of news articles and stuff related to contemporaneous events. All right. Furthermore, what topics or what categories do people share? From these data sets, from this smaller data set of 1,000, we picked Alexa.com to extract the manually assigned category for each of those domains in the 1,000 URLs. And we found that a lot of news articles, stuff related to movies, sports, and so on. It's not all celebrities, but it's a various collection. So we cannot just keep attention to celebrity-related stuff or only news articles. It's a wide range. All right. We have an understanding of what are the contents of this data set. Let's test it a lot more. So actually, we conducted this study. We took an entire snapshot of all the content of the resources in the dataset every 45 minutes, all right? Where in every snapshot we take a PNG snapshot of what the page looks like. We downloaded the HTML content. We downloaded all the Facebook likes, shares, and so on, and all the tweets that have been tweeted about this specific resource till that point in time. To give you an idea about the size, 1 month worth of data is 1 terabyte. Like for just over 1,000 URL, we have 1 terabyte of data to analyze, just 1 month. And we're actually planning to proceed with this experiment to the next year. So a lot of numbers to crunch. All right, so how do things change in time? All right, if we analyze it to extended period of time. We actually stopped the analysis, but it's still data like the data is being collected as we speak. But after 52 days, we paused and we started analyzing the data that we had. We noticed something. Resources, web pages do change between the time it was authored and the time it was clicked. Up to within 1 hour, 4% of the resources have already changed by almost half, or third here. Within 6 hours, that doubles to 8%. So you can actually go to sleep, wake up, find something completely different in 1 out of 8 of the cases here. As you see, within a day, 12% of the resources. 1 out of 8, every 8 resources that you see on Twitter have already changed by the time you woke up from your sleep. All right? So we analyze the rate of change as we speak in time. Let's go back to the past. We want to check what is archived, since we access archives on a regular basis, and when the resource started appearing on the web. Remember, we analyzed the archived content in regards to the 6 historical events that we mentioned here earlier. We analyzed the percentage archived. Okay, these are very specialized event-related collections. We want more general notion, like on regular pages, on the regular web. To do so, we conducted in 2011 a study. We conducted a study where we extracted 4 different data sets from 4 different sources. First one, search engine indices. We utilized works of Shaw and Molina in randomly sampling search engine index. I randomly sampled the Google index to extract a sub-data set from Bitly collections, from DMOS, and furthermore from Delicious. With those 4 data sets, we started measuring how much of the web is archived. We found the answer is very simple. Depends. It depends actually where these resources are. Here we found that the percentages go from 16% of that content published on the web is archived to up to 97%. Very optimistic. Okay, our colleague Ahmed, he actually took the lead on this. After 2 years, he rechecked and reran the experiment again and found that percentages actually improved significantly because there is like a great reduction in the quarantine period of the Internet Archive, as well as the web engines cached versions. But if you think about it, it's like a Schrödinger's cat problem here. This became, since 2011, this data set became very famous and have been tested and studied by researchers consistently for the last 4 years. So the more you study it, the more it gets discovered, the more it gets indexed, the more it gets archived. So that doesn't really give us a real insight of what the web is, the amount of web is archived right now, and how well it's archived. All right. Our colleague Yasmin conducted a study that she's publishing a paper this year in regards to the content that had been archived, where it was shared in the social media. That's more my concern here, so I might ask her to push me in her next paper. I might help or something. I don't know. We published these results in GCDL in 2011. Here percentage of if it's archived or not as a binary notion. Another question appeared, and that's actually where Justin, our colleague Justin here, is taking the lead, and that's mainly his work. How well are these archived contents in the archives? Okay, we say that this resource have appeared on the archives or have been archived. How well it is? We published this paper, and we actually received the best student paper award in GCDL 2014, and were invited for a special journal in IGDL, a special edition of the Journal of IGDL 2015. Just got accepted. It's all his work. So. All right. So we analyzed the content archived. The next question, as I mentioned, when it was created. So, when I walked around here, from my office all the way here, I left footprints on the pavement and on the ground and all of this. So whenever you go anywhere, you leave a trail, you leave a footprint. All right. Same thing as web pages. When they occur, when they appear in different venues, they leave web trails, as we call them. Web trails in this sense are tweets, references, links, social media posts like Facebook posts, Facebook likes, a dig here, a delicious tag here, and so on. Since we don't know the creation date of resources, ideally every resource would have its own, I have been created on May 5th, blah, blah, blah. No, not all of them. Actually, less than 50% have this. And in a lot of cases, this timestamp is not correct. So, we assume the life cycle of a web resource or a web page that has been created shortly after that. Someone has tweeted something about it, Facebook shared it, was picked up into search engines, after that it was archived, and so on. And it could have changed at one point in time. Since we don't have this date, if we can get the leftmost estimate, that becomes very short distance from when it was created. All right. To do so, we mined 6 different sources. First, we checked if there is a last notified date in the response headers or not. All right. Second is when it was first appearing in the archives or as a backlink. The first tweet have ever been published in regards to this. First time someone shortened a URL about this resource, and the date of the last scroll in the search engine. All of these can provide us with the timestamps. If we got the leftmost of these or the one that is further in the past, we can have a real good estimate of when it was created. We built a service, we named it Carbon Dating API, and we provided here in this URL where you can plug your URL and it can extract our estimate, our 6 different estimates. This is the JSON breakdown of these dates. For example, in Bitly, this is the date that have been estimated, in Google search engine and so on, and it gets our estimated creation date here. All right, we created this service. How are we going to evaluate that? All right, we provide this service or provide this algorithm to estimate the creation date. How we validate it, how we evaluate this algorithm. To do so, we extracted 1,200 instances from 12 different sources. Some of them are news websites, some of them are social websites, and some of them have been manually extracted from top domains or random pages. Every single one of these resources, we know for sure the creation date for it. Either it's a timestamp on the page itself, like a news article, or some other cue that tells us when this page was created. So we apply our algorithm and see how close we got. In this case, we actually got an estimate in 76% of the cases. Third of the entire data set, we reached the exact same creation date up to the same day. As we see here, the red dots are our estimate. The blue line is the real creation date. The closer we get to the blue line, the better our estimate. And this is the age of the resource in hours. Yes, we see a couple of points where our estimate was a whole lot of hours from, like here for example, from the real creation date. But in most cases, we were fairly close. As you see here, a lot of red dots here. So in this case, our estimate extracted a creation date or estimated a creation date for 76% of the cases. A third of the entire data set was the exact creation date. We published these results in Doctoral 2013. Furthermore, our colleague Alex, raise your hand. That's Alex, okay. He took over the carbon dating project and took it a whole new level. He introduced multi-threading in it, became more reliable, had more capabilities in caching, and it's faster and all of that. And yes, it's better than mine. I admit it. All right. So next, 2 down, 1 to go, and a very important one here: the user, the tricky part of the equation. So as we said, we have a problem. There is inconsistency between what the author have intended for you to see, and we introduce here t-tweet, which is time at tweet time, and what the reader might actually read when he click on it, time of clicking. All right, so first step is we want to detect intention. All right, we want to understand what that is. So ideally, we thought that we utilized Amazon Mechanical Turk. For those who don't know Amazon Mechanical Turk, it's a marketplace where you create human intelligent tasks and ask people to assign names or categories for each of these tasks. That's where you collect data for your analysis. A lot of researchers use it on a regular basis. So our thought is collect a bunch of tweets, plug them in Mechanical Turk, collect the data, train a classifier, build a model, and be so happy about it. It's not as easy as it seems, all right? The thing is, this is a snapshot of the experiment that we built, one of the first experiments that we built. We placed the social post or the tweet here, and here, if you cannot see, oh my God, I can't believe Michael Jackson just died. And we asked the Turkers, did the author intend for you to see the current version, the current version on the live web right now, or the one that he saw at the time of tweet? This seems trivial. It proved that it's not really as trivial for Mechanical Turkers, because most of the cases the tweets are not that clear. All right, to do so, to validate if we can use Mechanical Turk as a good way to collect data, we gathered the WSDL members, our research group, and asked them for each of the subsample, the data set of 100 tweet resources, the pairs, and we asked them what is the intention behind each one of them. Then we conducted the experiment on Mechanical Turk and saw and calculated the similarity or agreement in this case. We found that there is an agreement in 31% of the cases, which is actually worse than flipping a coin. So that proved to be a terrible idea. All right, so we did a lot of analysis, a lot of studies to understand why this happened. Why Mechanical Turkers did a hell of a terrible job in doing this, okay? Why didn't they understand what we understand of intention and time and all of that? A lot of studies mention that Mechanical Turkers, or normal people who don't have a strong, solid grasp of time, don't recognize these tasks or are not really good at it. But what they are good at are relevance tasks that require a simple visual cue or a simple one task. Is this a cat? Yes, no. If I ask this entire room, we will reach the same conclusion. This is a cat. Cute one. All right, so we want to transform our hard problem, the one that is highly subjective, with a lot of human point of view, to a simpler task of relevance that Mechanical Turkers are awesome at. To do so, we noticed something. The resource could have changed or not changed from the time it was tweeted by the author. Furthermore, the tweet in relation to the current state of the resource are still relevant or not relevant at all. To further analyze this, we noticed 4 different scenarios. First here, this is a tweet from Pfizer.com, okay, where they urge their consumers or their followers to check out the newsletter or webpage with the latest updated news. This is actually intuitively we see that this page changed on a changed regularly, okay? So it changed from when Pfizer have posted, and it's still changed till now. It's still relevant to the tweet. If you click on it, you're still happy to see this, right? So in this case, Pfizer wanted you to see the current version of the resource at any point in time. That's one case. Furthermore, we place it here in this quadrant. Jeff here tweeted about Michael Jackson dying, and he placed the link of CNN.com in his tweet. Don't do that, okay? When you click on CNN.com, you see here the state of CNN talking about, at that time, about Zimmerman and the trial and all of this. This is not what Jeff intended for you to see. He wanted you to see the past version he saw. So in this case, the resource has changed and no longer relevant. So the past version. Place it here. Furthermore, Chris published a link to an article in New Scientist here. The article didn't change since he saw it, but it's still relevant. So in this case, he wants you to see the past version. Place it here. And this actually is the most common case in social media content. Finally, just to cover all the angles, in some cases, the resource have not changed, but it's still not relevant or never was relevant to the tweet. And that's happened a lot in spam and a lot of malware and stuff like that. So we're not quite sure what did they intend for you to see here. With these 4, we mapped intention perceived by the reader, conveyed by the author, in terms of relevance and change. So, and this is our temporal intention relevancy model. To prove it actually works, we built this mechanical Turk experiment where we place the tweet and ask the simple question, and the current state of the resource, are they still talking about the same thing or not? And we asked for 5 different votes for mechanical Turkers, and we removed the close calls, and by asking also the WSDL members, the experts in web research and time research and archived content, we found almost perfect agreement with mechanical Turkers. So that proved that yes, we can detect intention, and we can use mechanical Turkers to actually express intention in terms of relevancy and change. We can measure change by a whole lot of algorithms that measure the difference between one version of the resource and another. Second step is we need to model that. To do so, we built a data set where we collected data from Snap here. Snap is a Stanford 500 million tweets data set that I mentioned earlier. For each one of these, the tweet is in English, has a link to an external resource that still exists in the current web right now, and for each of these resources, it have 10 mementos, or snapshots in time, and it's unique. From the archived content or the snapshots, we extracted the closest memento to the time of the tweet to see what did the author see at the point where he tweeted this content, all right? And like for the randomly selected 1100 instances, the top 1000, we found that the average time between the closest memento and when it was tweeted was 25 hours. So we assumed that this is what the author saw. It's an assumption here. So after removing the close calls, we found that 82% of the cases are relevant, 18% are non-relevant. All right, we have the assignments. Let's extract the features now so we can build our machine learning model. To do so, we extracted features in regards to link analysis, social media analysis, archival existence, sentiment analysis, content similarity, and entity identification of finding entities within the textual content posted by the author expert. All right. With all of these features, we extracted 39 different features. Remember, this is an exploratory study because we didn't know what we were looking for in the first place. What factors affect the intention? Would the temperature of the room when he tweeted this tweet affect the intention? I don't know. To do so, we extracted all the features that we can actually grasp, and we analyzed them. We extracted 39 different features, and we trained a cost-sensitive classifier based on random forest, and we reach a 90% accuracy in modeling using those features, in modeling relevance. And these are the features based on information gain. They'll give you an insight of what the features are. There is similarity, there is sentiment, and so on. I'll get back to these features in a second. We tested our results from the, remember this is a sub-data set of 1100 instances from the 6,000 original ones, and these are the rest. We tested them. All right, so we built a model, we validated it actually works, and it can estimate relevance. We need to, okay, this is not a problem of relevance, it's a problem of intention. We map it back using relevance and using similarity. In this case, we utilize cosine similarity. We map it back to intention. In this case, we are concerned about this quadrant where the content has changed and it's no longer relevant, so you're actually physically reading wrong history. And we found a staggering up to 25% of the cases you are literally reading wrong history after analyzing the data sets. All right, this is the interesting part. Using 70% similarity as a threshold where we deem something, it's similar or it has changed, okay? All right, so the three main results from this experiment is we detected intention. We understood what intention is right now. We mapped it to two simpler tasks of relevance and change. Furthermore, we built a gold standard data set that have been publicly published to all the researchers in the field to be utilized in understanding intention. The more experiments, the better. Finally, we were able to detect this temporal inconsistency in 25% of the cases. We published these results in GCDR 2013. We modeled intention. First make it run, then make it run faster. How can we make it better? To understand how we can make it better, let's look at the features and how they affect the machine learning model, okay? In this case, we noticed something fairly interesting. Two of the features, all right, have the highest information gain ratio. These are ranked. 39 features, we ranked them, we got the top 6. One here is a peculiar one, like we simply checked if there is a celebrity in the tweet, if there is a mention of a celebrity in the tweet or not. We used the celebrity list from Wikipedia. If this tweet talking about Lady Gaga, most likely someone is talking about a very current event, all right? So that gives us a cue that we need further linguistic analysis. We need to understand what the author have been writing and how he has been writing and about what that he was writing. To do so, we did a lot of analysis in NLP, natural language processing, and during this period where we enhanced our model, I was actually interning in, as an invited researcher in National University of Singapore at the NLP group there. They are experts, world experts in this field. So they taught me a lot. All right, so we did a lot of extended features in regards to linguistic analysis, semantic similarity. Remember the data set was 82% relevant, 18% non-relevant. We wanted to balance that to remove the bias. Furthermore, we wanted to select the minimal amount of effective features that we can use. The reason I'm mentioning minimal amount because we actually ended up from 39 features to 65 features. And I'll not go into every one of them because there are a lot, okay? So if you want more information, find chapter 7 in my dissertation. All right, so this is the prior term. Okay, term is our temporal attention relevancy model, and this is after we enhanced it. We enhanced it by 8%, from 82% to 90%, and we minimized it. All right, so far, I can say if it's relevant or not, if the intention is current or past. But another question appeared, how current it is, or how past it is. So far it's been binary, but we want to know the strength of this binary selection. To do so, we formulated intention as a measure of strength of intention, as a measure of relevance and change in a probabilistic manner. I'm not going into extreme detail on how to formulate this, but you can find it also in chapter 7. But the conclusion is, with this formula, we were able to extract a measure of intention for each of the tweet resource pair that varies from -1 to 1, -1 meaning the past intention, 1 meaning the current intention, and we plotted this for the entire data set of 1100. And we found that actually follows a very nice sigmoid function. All right, talking about intention formulation, -1 to 1, what do I mean with that? I want you to look at this tweet. Here Phil is talking about if you're interested about something, about this new startup, check out their webpage. He wants you to check out the webpage as it appears at any point in time, because if they publish something new, you gotta check it out. We found that the intention strength for this was 73 towards the current. As you see here, blue is for the current. Furthermore, Heather Meeker here was saying that's during 2009 outbreak of H1N1. Here, the latest number, the number that she saw at that point in time was 47 of the casualties. So the intention strength that we calculated was 82% towards the past. She wants you to check out the past version, as we see here for the green. All right, we detected, we modeled the intention. Can we predict it? At the point in time when the author have actually tweeted this, can we predict it at that point? Let's see. To do so, we want to check the intention strength at every point in time when we go to the past from the current all the way till the time that he tweeted this resource or shared it. And how this intention strength changed, or did change or not. Let's see. To do so, the same data set, if you recall, we had this requirement that it has at least 10 mementos, uniformly distributed from the time it was tweeted till the time it was clicked. Here, it was tweeted, here it was clicked. We have 10 mementos. This is a span of 3.5 years, so it's fairly significant. So we have 12 snapshots, 10 mementos, the current state of the resource, the past state of resource with the closest memento. From these 12, for each of the resources in our data set of 1100 instances, we analyzed them against time. We found something, that if we calculate the intention strength for each one of those instances, we found very peculiar scenarios. In some cases, it's expected. Here, the current intention is steady across time. Sometimes it's steady in the past. Okay, I want you to check out the past version all the time. Sometimes it changes. And that's the one that we were aiming to further analyze. This is the interesting part. To give you an example of what I'm talking about, here, when Jeff said Michael Jackson had died and he linked to CNN.com, the beginning, CNN.com was still featuring the Michael Jackson story. But as we go through time, it changed and it stopped stopped talking about Michael Jackson and started talking about other events and disasters and so on. And here, steady past and the steady current. All right. So, a question here appeared. Given the features that we have extracted so far, all right, and that our trained model, our understanding, can we predict it? All right, predict those behavioral classes. First, let's create a classifier that can detect those classes, and then we'll predict it. So yes, we can actually detect those classes in 89% with 89% accuracy. Furthermore, if I limit it only from the 65 features, only the features that I can extract at the time it was tweeted by the author, if I removed all the other features that I can extract later, I was able to perform a prediction in 77% accuracy. So 3 out of 4 tweets, I'm going to give you a correct predictions of the behavior of the class. With this intention is going to change through time or not, while you are writing the tweet. And here, this is the prediction, the prediction F measure, and we call them precision. So this is our conclusion. In 70% accuracy, we were able to perform this prediction, and we published these results in 2015. All right, so we successfully detected intention, modeled it perfectly, and predicted. What's next? So we built our user intertemporal intention relevancy model and validated it. Let's use it, okay? So we have a scenario here. We have an author, a T-tweet. He needs tools, he needs knowledge of if this resource is gonna change or not, if it's gonna disappear, and so on. At the time it was clicked, the reader needs knowledge if this is the same version that the author intended for you to see or not. We built a model that predicted, that gave them tools. So in this we proposed a framework where we utilized our prediction engine to build a very simple interface where you plug in your tweet and the link to a shared resource and run our prediction engine, and it will give you educated knowledge if this resource is going to change through time or not, and give you the power of tools to actually do something about it. Here, plugging the same tweet that Heather Meeker said, check out the casualties number right now is 47. it predicted, like when she pressed tweet, predicted an unsteady changing behavior that's going to happen to the specific resource, and give a recommendation up to 60% like confidence to that it's changing. And it gives you tools and power to preserve history by actually taking a snapshot of like the current state of the resource that she's seeing right now. It's going to change, beware. Take a snapshot of this resource, push it into one of the public archives and link to that instead. So at any point in time, all the people on Heather's circle will see the current state that she saw at that point in time. Also, this has a side effect that would increase the quality and the quantity of archived content. Furthermore, this is in regards to the author. What about the reader? First, we did a pilot analysis to see how people interact with the concept of time and archived versions of the web. So we built this hover tool, where whenever you hover with your mouse without even clicking on any URL, it extracts the available mementos for it and how they change through time and give you enough context and knowledge where you can navigate the past web while you are navigating your Twitter. And we publish these results. We published this prototype for users to use. Furthermore, using our prediction engine, we can provide an indicated guesses or knowledge about the state of the resource at the time it was authored. Furthermore, we used this. We implemented this cover flow form, like in iTunes, where you can navigate the past web while you are clicking on certain links in Twitter. Like here in Twitter, when you click on this link, this will appear to you and appended to the regular page, the current version of the page, appended to it a banner where you can go back in the past and with the percentage of similarity for each. And our prediction. And we are planning to publish these results in this year's WSDM, our proposed framework. So, how do we conclude this? For our goals, we managed to detect temporal intention successfully and understand what the author intended for the readers to read and what the readers experience at the point of clicking. Furthermore, we modeled this. We built a classifier, a machine learning model that can model this intention at any point in time. Furthermore, we predict this intention at the time of authoring of the tweet. Furthermore, we proposed a framework of tools, a suite of tools that can utilize this prediction to better maintain the consistency of the web. And that's our initial goal. Beyond accomplishing those goals, we reach a little bit of fame, as a researcher might get. I was featured in the front page of the Virginia Pilot, in regards to my research. Our work have been featured in BBC.com, and it was translated after that into 7 different languages. Our work have been featured in Popular Mechanics in the issue of February 2014. My work personally, and there is another paper with Scott. It was featured in MIT Technology Review 3 times for my 3 papers. Finally, in Mashable, we have been called the Internet Archaeologists. Yes, I'm Indiana Jones of the Internet. So, yeah. This is also another form of success, I believe. The publications that have been already published, submitted, and planned during this year. And I want you to go back with me to the very beginning. Remember Remy Oshlik? Remember when his stuff have been missing? When you click on it, you find something that is completely not there. The collection of his works, the work that he lost his life for, have been missing. Using our model, we can revive that. We can avoid these things happening from the content of Remy's work. Here, for example, the British Journal of Photography. This is the edition that here Ron meant in regards to Remy Oshlik and his collective works. Using our model, we can give the knowledge to the author and the reader to find this work and revive the memory of Remy. So, thank you so much. Thank you for the time.
Okay, questions from the audience for Hany?
Yes.
See, slide 152.
132.
Yeah, sorry. No problem.
132 or 150? 152.
Okay. Yeah, let's do the 232.
Continue.
Yes.
Repeat the question, please.
Yes, okay.
I was just curious, I see you did tenfold cross-validation testing. I was
Yes.
wondering, did you use consistent classifiers or some other?
No, I actually, the point in here that we wanted to check this behavior. Let me go back. This behavior here. To understand this behavior, we have those instances in time. All right, if we did a linear regression to all of these instances in time, and we found that the slope is 0, or almost 0, and intercept is in the negative, we know it's in the past. If we found the slope is bigger than a certain value, we know it's changing. With this knowledge, we train the classifier. I'm not concerned here of the best available classifier for this. I can actually tailor one later on, but I utilize the Weka suite based on those features that I extracted and get the best classifier. In this case, it was actually random forest because it comprises multiple classifiers that randomly work together and so on. It gets the best configuration. But this is what we are trying to classify, this slope and the intercept. All right, and yeah. Yes. Thank you. Any questions?
Other questions for Hany?
Don't be
Surely
shy.
there are other questions for Hany.
Was my work that awesome? All right.
One more time.
Any questions?
All right, we're good.
Yes.
We'll just stay with Sean until somebody else raises.
Sean? All right.
On slide 40, it's not so much the slide, but when you were doing the study with Twitter and the hashtag, how did you determine which hashtags to choose? Like, one of them you had Obama and then Nobel Prize. It's possible so they could shove those together and have Obama Nobel Prize as a hashtag.
That's actually an awesome question. And let me go back to the slide so I can actually explain to you what I mean. For each one of these events, remember they're related to a historic event, all right? We know trivially that it's wait. I got excited with it later. Yeah, here. So we know trivially where to start. For example, H1N1 outbreak, okay? We know that most of the tweets or some of the tweets will have the word H1N1 as a hashtag. Trivially, okay? But we don't know what else would appear. To get the rest of them, we picked the data set of the half billion tweets and extracted all the tweets that have hashtag H1N1. And we extracted all the co-occurring hashtags that appeared with H1N1 and ranked them according to appearance. In this case, for example, swine flu appeared like 56,000 times out of the 61,000 that had H1N1 only. But with all of that, we selected hashtags that co-occur together. For example, H1 and swine flu are 3 hashtags, appeared in 42,000 tweets. So most definitely, these tweets are talking about this event. All right? It actually appears the significance of it, maybe H1N1, not really in this example, Obama or Michael. Maybe it's Michael Schumacher, the race car driver, or Michael Jordan or something. But Michael Jackson are significantly fewer. And also we limited the amount of time because this data set is from June 2009 till November 2009. So anything related to Michael Jackson is most likely about his death. Okay? All right. Thank you. Any further questions? Yes.
So where you divided your data set in 4 quadrants, like where you're trying to understand what
Sure.
pages will go in past and current.
Let me get back to this slide. Wait, I skipped this. Here. Okay.
So what is the third one?
The third one here, the resource has not changed. This is the article that Chris tweeted about in the New Scientist saying
so it's still relevant and it's not changed.
it hasn't changed and it's still relevant. Okay, so it's most likely this is where Chris wanted you to check out the article as it existed. But at the same time, it's equally probable that he is okay with you checking out the current version.
Exactly.
Okay, so it's actually a more solid true positive. Okay.
To me, it's like don't care situation where you
Assume this way. This is a don't care. This is uncertain. This is, oh my God, we did something terrible. and this is, I have no idea, okay, because this is spam, all right? This is quite often, like 70% of the data set is in this category, which is what you see on a regular basis. When you click on something, you see the current state of it was and it didn't change, so I'm happy. But that's what I'm concerned about, where you click on something and it changed. Sometimes this change is subtle. Like actually there is a case in the Egyptian Revolution where journalists have changed their opinion after the president was kicked out. And when you click on their articles, it goes to their new opinion. Before they were like, Mubarak was awesome, the president is God. But after that, they're like, oh, he was terrible. It's the same link, but they changed the content. And that's what we are concerned about. Right.
So I was thinking, like, I mean, if I had to build a tool, I'd probably put the current one here rather than past, because that will give some more recent information on the page.
That's actually true, but see here, this is what I'm concerned about. Okay, this is second quadrant.
Right.
So you could view the resource hasn't changed. If I insert the word hasn't changed yet, then it's at the point where the archive version and the current version are the same, it really doesn't matter. So
Right.
If you have access to archives, cool. Current version, cool. Matt?
At one point you said something about 7% of content change being the threshold for
Yes.
for determining when a page has sufficient change. What is the basis for 7%?
70% is actually empirically from other related, for example, most of the work for Shoam and Malena in regards to the freshness of the archives and the crawler frequency of archived content and changing content, they're all using the 70% threshold. Okay? It seems empirical, but it's good enough. So in this sense, so yeah, that's why I used it. I used what the Greek people did used.
So if I always show the past version or the version of the page where it was tweeted or mentioned, how will it be like? In how many cases it will be like? I know situations where you say a scrolling page which changes over time, but you want them to see the current version basically.
The thing is, okay, remember the example with Pfizer? Okay, sorry. I want to show you this because that question has been asked before. Here, remember the example with Pfizer?
Mm-hmm.
If I always, like everyone thinking, all right, cool, so let's do a tool whenever you tweet something, it takes a snapshot and link to it just out of the box. In a lot of cases, this is not what you want. Here, for example, you don't want to see the latest news from a year ago. You want a model that can actually detect the difference between that and know when to provide you with the current version or the past version. In this case, I don't want the past version at all.
I understand, but what I'm saying is like how much is the situation, like 2%, 10%, 50%? How many cases such?
Yeah, as we said here, this happened 25% of the cases. This is, I don't
go
know.
to that slide.
That slide, okay. Let me.
I think it was 1.3.
Yeah, here. As you see the percentages here, that goes up to 25%, all depending on the event where the collection is available. Here, up to 53% of the cases, okay, in those collections. And here, see, as you see, it's more common, it's 91% of the cases. All right?
I don't know that that was the question.
Okay, what your...
Did I answer your question? If it did, I'll ask
So,
similar later.
all right.
Okay,
I think that answered Sue's question. You might have a
Okay.
question.
okay.
Because basically you could always choose the current, which is the default behavior, or always choose the past, and you'd end up in one of those quadrants he's now clicked away from.
Yeah.
And you could figure out, now the numbers vary based on the
It was
event
133.
collection.
See, in these quadrants.
No,
And the percentages?
Yeah.
Yeah, here.
So, and you can look at this and figure out
If-
for a particular collection.
If you stuck with a certain decision, either the present or the past, you are always bound to have an error. If you stuck with the current version, you'll have up to 25% error. If you stuck with the past version, you'll have up to 53% error in those collections. It all depends on the source or where this collection is available. Yes?
Yes. So we know that there are like many internet archives worldwide, like in San Francisco and all of this. So what are the type of internet resources being archived, and what are the models they are using to archive the content of the internet? And can your model be integrated with this?
That's a good question. See, there are almost a dozen, maybe 15 different publicly accessible archives where you can use your own laptop and access them. Some are specialized collections for like the British one or the French one for domains.fr, but the more common one was actually in the Internet Archive in San Francisco, and we work extensively with them. Actually, our colleague Ahmed did an internship there, and Hany SalahEldeen. So what they do is they utilize a web crawler called Heretics, where same as like if you know the search engines and how they find web pages, same thing as web crawlers. They have a page, okay, and download its content, create a memento, then find all the URLs that appeared in this page, and go to each one of them and add them to the queue and take a snapshot of them. Each one of those, get the all URLs that appeared in this page, and so on. I would love for the Internet Archive to create a modification for it to include web pages that appear on Twitter or something, like download the Twitter stream, the fire hose of the tweets that appear. Whenever they find a URL, take a snapshot of it. I would love that. But I don't think within the next 3-5 years that they will incorporate this. But to be completely fair, they're actually doing complete renovations every couple of years in the way they crawl. To give you an example, within the last year, they reduced the quarantine period. Like whenever they take a snapshot of the web resource, they keep it under collection, like not public for a certain period of time. It goes from 2 weeks up to a month. Then they release it for the public. Right now, they modified all their web crawlers. They made their content more publicly available faster, and you can actually access mementos that have been created yesterday. So they are improving. I don't know if they're gonna include social media related content or resources that are published on social media or not. Let's hope. But if they utilize my model, yeah, that'll be awesome. Thank you. Other questions?
So point out Ahmed Alsam's dissertation cited in yours as an in-depth description about the behavior of various archives.
Yeah.
But using Memento, he accessed the Internet Archive and a dozen or more other archives all at once.
To give a little bit of context as well, our research group, each one of us is taking a specific angle of the problem. I'm concerned more about the social media aspect of it. Ahmed of how content is archived in the public archives. Justin, for example, the quality of the archives and how the different representations are archived. Matt in another aspect, and so on. So every one of our group is like focused or an expert in a specific angle of the problem. It's a big problem. Time on the web.
All right. Other questions? All right. We'll move to the committee. Who wants to go first? Michelle, you had a question locked and loaded?
Well, I mean, I have several questions,
Okay.
so I can wait if you want to.
Okay, I'll ask you a very philosophical question. You have a PhD in computer science. What is your work relevant to computer sciences? What did you learn in computer science that makes you unique to do that thesis? Answer that question.
All right. Actually, I can answer this question with the example of Remy Oslik's work, the French photographer. My work, if it was incorporated in tools for authors and readers, can actually maintain the consistency of the web. No more breaks, no more missing content, no more stuff that journalists and photographers or people on the street, because there's like thousands of people who died during the process. Some of them died because they were blogging, they were taking a picture. With my model, this content will not disappear.
No, you don't understand my question.
Yes.
Why are you getting a PhD in computer science? Why your thesis is classified as a computer science? Can you take your thesis and go to electrical engineering, say, I like to get a PhD in electrical engineering?
Okay, that's much more.
That's my
question.
You know? What did you learn in computer science? For example, data structures, say databases, statistical. What is the relevance of your work to computer science? So you say, I got my PhD in computer science, not from, say, library science or, you know.
Well,
So
Yeah, my
Just-
PhD is
For example, what kind of programming language you use, what kind of data
Yeah.
structures you use, what will taught you as a computer science make you to do that good work in your thesis?
okay. Well, I had to learn a lot about behavioral analysis and modeling and building a classifier and feature extraction. And I gave a lecture like recently for new upcoming students on the art and science behind extracting features in data mining. How to extract the best feature, how this feature would be significant. Okay, some stuff are fairly simple and trivial to see. Like there is an art and science, I believe there is an art and science in everything that we do. We go from designing a mechanical Turk experiment and understanding how people would perceive an experiment, how people would react to it. I had to learn that the hard way. And during my course, with my term here, I learned a lot of data sets and data structures and how to explore and how to build consistent data. For example, in detecting the rate of change, the experiment that we built and with the help of our colleague Mustafa, and he's working in Amazon, to build a sustained experiment that ran every 45 minutes for the course of a year is way harder than you would think. We need to create fail-safes and build something very reliable and actually build scripts that send us emails and notifications when something goes wrong. That's one thing. Furthermore, during my, as I said, like when I went to Singapore, I learned a lot of natural language processing. I was like reading courses from the very beginning on how to understand natural language processing, how to detect things like that, and sentiment and all of this. So yeah, I learned a lot during this course, the course of this research.
Yeah, but for example, you mentioned about Alex. He took your work and make it more efficient because you created multi-threading and you do a lot of truly computer science contribution. So that's my question to you.
Yes. Yes.
So I know that
So,
Alex is using skills
Well,
as a
to
computer
be honest,
scientist to improve the efficiency and the response of your
the
work.
thing is, okay, I have been doing this for like in this program for 5.5 years. So, and during those 5.5 years, I've been in like running constantly. So after we built a carbon date, for example, Professor Nelson wanted me to make it more sustainable, more reliable, that everyone can handle it, handle like 1,000 requests. But at the same time, I was working on 3 different experiments. So that took a long time to sustain and work with. But at the same time, Alex, thankfully, joined our program. And I mentored him for a little while, so that actually taught me how to mentor, how to hand over projects, and he was brilliant and took it over and made it way better. And I have no shame in admitting that because I think he's way better engineer than I am, but I'm a better scientist. I'm kidding.
Well, okay, that's fine.
So
I'll give
thank you.
a chance for some other.
Okay.
Yes, well, first of all, I would like to congratulate you for your outstanding work. Really, for an outsider like me, I really enjoyed reading your thesis.
Thank you.
And I learned a lot from it. And I have 2 or 3 questions. The first one actually relates to because you mentioned that you included the linguistic analysis in the model itself. And we know that one of the weaknesses of the linguistic analysis in machine learning in general is the semantics in general,
Yes.
in terms of, so if you can perhaps just elaborate a little bit, for example,
Absolutely.
how would you address this?
Yes.
Particularly because you are talking about intention.
Yes.
And intention, as you define it here, is based in terms of relevance and change, and there are other dimensions. So perhaps that would be my first
Absolutely.
question.
Okay. The first thing I learned actually, while understanding what natural language processing is, and actually Dr. Minian Khan from Singapore told me this, you need to know that you are analyzing what humans speak of or what the humans talk about, and it's highly subjective. And in a lot of cases, you need to admit failure before you can start. Okay? Because why am I saying this? Because in a lot of cases, people share stuff with a sarcastic tone. Okay, that's the highest research topic right now. How to detect sarcasm? It's very hard to do because there are certain things that you can actually, when you're talking to someone face to face, you can extract as features if he was sarcastic or not. The way his tone, his voice, his body language, and all of these are actually, in machine learning, are features. If he was grumpy or he was like laughing like this, most likely he is sarcastic. That gets tremendously harder when you are reading just textual content that is limited to 140 characters. If it was a paragraph, maybe you can detect that, like, for example, works of authors and stuff like that, you know a certain way they speak. And you can train a classifier to detect the way they speak and classify if this was a paragraph from this author or not. But with a large data set of random authors or random users, it becomes significantly harder. But even though with all of this, there are certain things that you can study and detect very easily. Like, for example, sentiment. Okay, was the author happy while he was conveying this sentence or not? There is also the factor of sarcasm, but we'll not mention that. But certain mention of specific words, using of capitalization, using of exclamation point, for example. All of this can work as features to explain in a probabilistic manner if this author was happy, or was he angry, was he saying this is the best movie ever, or this is a terrible movie, okay? Use of word best or terrible, it could be a clue. Furthermore, like, okay, this is the worst time I spend or something like that is also another clue. So a collection of all of these, you can train a machine learning, behavioral, natural language processing model that can take all of these clues, given though the small context of 140 characters, and understand that. But most of them are actually very targeted. Like you can build an entire classifier with multiple levels of details that can target only sentiment or only tone, like the reading tone or something like that. Some other stuff are easier to detect, like is he talking about a person, about a celebrity, about a car, about a brand, because there are lists that are available in Wikipedia. And that's actually what we used. We have lists of all English-speaking artists in actors, actresses, singers, and so on. And we mined, are they available in this tweet or not, with the short forms, Lady Gaga or MJ, Michael Jackson, and all of this. So that was easier to, yeah. Thank you.
All right, so since we're on this slide and you have this box highlighted, what is up with the Syria data set? Why, I mean, it's, you know, it's much higher here where it's changed and not relevant than the other data sets.
Actually, that's a question. In regards to the Syria data set specifically and the Egyptian data set, Dr. Nansan and I were talking about this, manually expecting, we found a lot of data had changed for reasons that are not related to web science or something like our preservation or any of that, but actually in a lot of cases for fear of reprisal. Like there are actually in Egypt, for example, certain agencies that go and find blogs where people are active or cursing at the government or something and imprison them. So a lot of people at a certain way that I found manually, but I couldn't find it algorithmically, but you can find it that they change their content almost overnight. Like for example, at one point there is an activist called Wael Ghunim during the Egyptian revolution. He was very active and people were encouraged by him. When he got imprisoned, everyone either deactivated their accounts, removed their content, disabled it, and so on. So in data sets in regards to Syrian uprising and Egyptian, this actually happened quite a lot. So that could be a certain explanation. Further explanations, we didn't really further analyze them as per data set, but that's my educated guess, I believe.
Okay.
Well, hold on. So there's some sample bias in here as well.
Yes.
I think you should address this, right? So Syria is different from all these 2009 events.
Exactly, because in 2009, it's a data set that have been captured by Stanford, and they are provided as a solid collection that has the textual content of the tweet and the resource. A lot of the tweets that have been in the Snap dataset are already non-existent, but they took a snapshot of this tweet and saved it. That's actually one of the reasons Twitter have pulled off the plug on the Snap dataset and asked them to remove it. And we contacted Stanford to get this dataset offline without anyone knowing. But a lot of people were pissed off because, like, I tweeted something, I have the right to delete it. In Stanford, in the Snap dataset, they took a snapshot of this entire thing, and there is no way to delete it, even with aggregation. Furthermore, here in the Syrian dataset, we extracted it using the Twitter API. So it was alive and healthy at the time that we extracted it in 2012. So there's a slight bias here as well.
But the difference in time between the linked resource,
Yes.
right, but I want you to address the sample bias that's present in retroactively pulling stuff from 2009 versus at the time current 2012.
Exactly. So when we conducted the study, this was actually in 2012. So the freshest data set that we had in our possession was the Syrian data set. So most of the content have been, as we proved, fresh. It's been right now been posted and reposted in the current web. But the rest of the data set, the SNAP data set, the freshest one was 3 years old. And that inherently has a humongous bias in regards to change. So, that understood?
For the 2009, haven't we already eliminated things that have less than a certain number of mementos?
Of mementos, like the entire data set is, every single one of them has at least 10 mementos available.
All right. So in general, address the difference between web archiving circa 2009 and 2012 to 2013. How is the archiving work different? Sorry, I'm hijacking the
That's
question,
okay.
but it's relevant to your answer. I don't want to.
Okay, in regards to the collected archive content? Or?
Archives operate independent of us, right? How was the world archiving stuff in 2009, and how was it archiving in stuff in 2012 all the way to 2015?
Okay, as you can see, like there is a 3 year difference between those three points in time. What happened, as I mentioned before, the technologies that the Internet Archive, for example, in San Francisco have been using, they updated their crawlers, Heritrix 3 right now. The technology, the way they archive content and discover content changed tremendously. In 2009, as we proved, the archive content was significantly lower than what Ahmed found in 2013, for example. That's generally speaking for archived content. So luckily, as we go to the future, the archived content improves, it gets more content, it gets archived. But the question is how well it's archived and how efficient, how good descriptive way of archiving it is. And that's the work actually of Justin, and he's the expert in this field. So
the answer I'm looking for to get is 2009, there are a lot fewer archives operating.
Yeah, availability for public archive right now, there
And they
is
archive
16.
at a much lower rate. So if you set a threshold of have to have at least 10 mementos, you're going to eliminate right up front a bunch of things that don't have that many copies.
Exactly.
And so these are sort of, the
only
2009 numbers are sort of, could be much higher if we remove them.
Remove the restriction of the 10 mementos, for example. But I needed this restriction so I can map it through time later on during those 3.5 years. To bear in mind, in 2009, there was around 6-7 public archives, and the Internet Archive was the monster with it. Like they covered like 90% of the archive content. Right now, there are almost 16, and a lot of them are actually, a couple of them were user-based content where every one of us can build his own collection of archive content and tag it.
So, related to this, was the domain of the linked resource, was that one of the features that you looked at? I was just
Yes.
wondering if things like YouTube or there were particular domains that like map to one of these quadrants more often, or more likely to
As you
change.
analyzed earlier in the datasets, okay, one of the features in the dataset that we were analyzing is the depth of the URL. Okay, because as I said, like cnn.com/word,
Right.
most likely it's going to change more than /word at 2009/December, blah blah blah, and so on. Okay, so the depth of the URL managed to be one of the features. The type of the domain, the category of it. For example, YouTube stuff tend to get archived less than other stuff. Okay, so this is one of the features. So we analyzed a lot of the link structure. Okay. And also in regards to like how many times it was bitly shortened. Okay.
But I mean, is YouTube more likely to change? Or, are there domains that are more likely to
okay.
change? I mean,
Qualitative analysis based on domains was not really my scope here. I didn't extend the study to analyze per domain the archive content and how the rate changes. I didn't address this.
Yeah, I mean, I was just wondering, because that's one of the things that you can see in the tweet at the time of the tweet.
Yes.
Because if the bit.ly, you can dereference it and get the domain that it's at. So I was just wondering if that was a feature in your model and if that showed anything.
It wasn't, to be completely honest, it wasn't. But as I said, this is an introductory model to prove that it could be done. The 65 features, like from 39 to 65, that was 1 year.
Mm-hmm.
We added those extra, 26 features. If I worked on the problem 1 year more, I can reach 100 easy, okay, with the knowledge that I have now. So, yeah,
Okay.
when we started, we didn't really know what.
And this isn't a question of if you've done it, just are you aware, has there been some quantification of, because you just mentioned that URI path length, the longer ones we assume
Yes.
don't change because they're probably to articles, leaf nodes, and things like CNN.com. Are you aware of a study that has looked at that in particular?
Okay, well, in actually the paper of Cho and Molina, in regards to the refreshment policies of the crawlers in the archives and stuff they mentioned that as an observation. They didn't specifically calculate this or did a qualitative study, like measuring the correlation between the depth and the way it changes. So that defines a difference, okay? But in our analysis, we didn't really, or there is no other resources or other reference that can manage to tell us what's the correlation.
Mm-hmm.
Okay.
Should I just ask all the questions then?
Sure.
Okay. So in your, did you get an idea of what's the percentage? How often do users mean T-tweet and how often do they mean T-click?
That actually could be found through this here. Okay. The 25% here for Syria, as a collective for the entire data set.
But
I
I'm
don't have
talking
the
about
collective number.
for a user.
I'm sorry?
I was thinking about, if you could figure this out from this table, but I'm not sure. I'm thinking of the user state, of the tweets.
Of the entire collection?
How many was the intention? And I was thinking maybe the -1 to 1 graph, does that
Yes.
give an indication?
Yeah, it can give us the two. Yeah, here. Okay.
So how many
is it-
dots below
Yeah.
horizontal, how many dots above horizontal?
It's almost 60-40. Okay.
Yeah.
I
But
didn't quantify it as a
To me,
number.
that's kind of surprising. Was that surprising to you?
It was, but here is the thing that I noticed. This area is very fuzzy.
Mhm.
Like there is a lot of false positives in this area here and there. That's why, for example, in the examples that I used here, I only picked the ones that are 70 and above.
Right.
There is a large percentage between negative 0.5, negative 0.65 and positive 0.65. There is the fuzzy area where we cannot really discriminatively differentiate between them.
Right.
So, and
But I remember when we were looking at these
Yes.
around the table, we're like, oh yeah, of course, you always want to do the past, right?
it wasn't.
And
this
so,
case.
yeah, I mean, this is kind of surprising to me
Yeah,
that there are
it's,
more that are, kind of T-click
It's
intensive.
exciting. You should question of it.
All right, another question. How often do you think that users find an old tweet and actually click on the link? What's the lag time?
Okay, this is actually not apparent in regular day-to-day Twitter checking out your timeline thing, but it's of crucial importance when you are analyzing collections that are related to historic events in the past. Okay, like the work of our colleague Yasmin, for example, she analyzes proposed a model of building tweet collections that tell a story. Okay, in regards to historic events. And there is a lot of work that have been done in regards to narrating history, like the work of Starbird, for example. And we worked on a project with the University of Wisconsin, actually in the psychology department and sociology, where they had collections of tweets related to the Arab uprising and the Arab Spring, for example, to build this collection where something like that is crucial because it affects the storytelling. So.
And is there something that Twitter's done recently that would increase the likelihood?
Yes, actually Twitter give you right now the possibility of going back all the way till 2006 when Twitter was first created, so you can navigate the tweets in the past. So this happens quite a lot.
And it will likely be more frequent
Oh, yeah.
as
Oh,
people
yeah.
take
Oh,
advantage
yeah.
of this.
The services will be built on that.
That's relatively recent, though.
Yeah, this was
Oh, yeah, yeah.
in the last 2 months, I believe. But that gives us an idea that several services, I can bet my money definitely, that they're going to build services that uses this. Build your own history, go back to the past, okay? Or specific to a certain event, can you build this, this story
I think
automatically?
that in their little demo of this, they have, look at the hashtag of this particular event, and, you use that as the.
Exactly, yeah, and you can scroll back into the past. I see a lot of potential here. Like, if I can build a startup, I will do this.
Or in blogs, we embed tweets, right? That sort of takes them out of sort of the ephemeral realm, makes them permanent.
Yeah, a lot of collection actually uses, and this happened with a politician when they found tweets that he wasn't able to use Twitter or something like that to go back as a reference. In articles, they include tweets as their point of reference or their point of evidence in this case. Yeah. So.
All right, and my last question, so
Yes.
for your real-time prediction, so how real is real-time? So how long does it take to do the
That's an awesome question. So here, if you see here, so what are we, okay, I'm going the other way, as usual. Here, see this? There is a reason this table exists, okay? I created, this is the past term, and this is the improved one, 65 features. That takes a long time to calculate with just a pair of a tweet and a resource. That's why we went with this route. Here we mapped, for each feature, there is a cost and there is a gain, all right? The gain is, you can measure it from the gain ratio of the features in the classifier, that's easy. But the cost of how many seconds or milliseconds did it cost us to extract this specific feature. We all know that the archives are very slow in extracting stuff. So downloading all the mementos that this specific resource had and comparing them across time, that takes a long time, actually up to 5 minutes. No one was writing a tweet and while pressing tweet, I'm gonna wait 5 minutes, I will make a cup of tea or something or a coffee and come back. That doesn't happen. To do this, so that implies that we want to rank them based on what are the best features that could be extracted within 1 second. And what are the best features that can, after 3 seconds, would it improve the classification or the prediction and in accuracy and recall and so on. So there is a whole potential in this in actually staging the feature extraction. What are the ones that you can extract in a second, like bit.ly creation, for example, the length of the URL, the depth for it, you can extract all of this in milliseconds, all right, and build, I don't know, about 20 different features in the first second.
So for people like me who type in a tweet and then read it like 15 times before you hit post, they would get better.
By the time, exactly, yeah. And it will run in the background, and as you update, it's like an Ajax update. While you are writing, it's calculating.
Mm-hmm.
So by the time you reach the point you are happy with your tweet and you are pressing post, it does that for you. Mm-hmm. And we are exploring actually doing it post-tweeting. Like you tweeted something, can I have an intermediate URL that let me decide later on which version I'm going to link to? We're still exploring this with bit.ly bundles and so on. So, yeah.
Okay. I'm done with my questions.
Any other questions?
Yeah, I have a question actually. I know your data sets are based on English language.
Yes.
Do you think that your model is applicable to other languages, i.e., for example, in Arabic in this case?
Yes.
Because I'm wondering whether, for example, the results of the Egypt and Syrian revolution would be different if we were using Arabic language data sets.
Actually, that's also a question. I did an internship in 2010 in Google. I worked in the MENA team, the Middle East and North Africa team, and I was working mainly on dialects. Okay, and the different dialects in Arabic language, in German and in English. In English, it's not quite apparent, like whatever you write, someone Australian or something from South Africa or Britain or here, the English is almost very similar. It differs significantly in German and in Arabic because the dialect where the slang terms appear is very prominent in other languages. So I find this is going to be fairly more interesting and like a PhD question by itself. So I expect a lot of research in this area, but I haven't explored it. but definitely welcome anyone in our group to take it over. I would love that. That would be awesome. But yeah.
So for the NLP, you're using like the Stanford tools, right?
Yes, I'm using NLTK tools,
NLTK.
NLTK tools, and Stanford. These tools are okay. Some tools we retrofitted them here and then checked the existence of entities and stuff. But some tools that have been tested and published for years, and we rely on their validity. Like the sentiment tool, for example. It would be extremely hard to implement one from the ground up, but using like the giants. Stanford.
So this sort of limits you to the tools that are available.
Yeah,
So if
there is not a lot
NLTK
of
does
tools.
Arabic, I don't know if it does.
I don't think it does Arabic, but there are other tools that detect entities in Arabic, so that's definitely there. So maybe depending on the language, either we translate and find features, or use the tools that are available for Arabic language and other languages as well. So it's a very interesting question to solve, but I don't think.
As an aside, I have to think the state of the tools for Arabic, they can't be good because I look at the Facebook translation, right?
Yes.
Those things are awful, right? So I just have to think the tools aren't there for.
The tools are actually specific, as I was talking about here in regards to dialect and slang. The tools are mostly designed for if you are writing in the standard high Arabic, okay, the Fusha, okay, in this case. Most of the tools are tailor-fitted for this standard high Arabic, okay? This is exactly the same case in German, all right? Because high German is totally different from Swiss German. I lived in Switzerland, I know. So most of the tools are fitted for the standard German, the standard Arabic, and so on. But when you add the slang terms that are apparent in English dialect, in Egyptian dialect, which differs significantly from Moroccan. I speak Arabic and I have no idea when my Moroccan friends that I speak, I have no idea what they are talking about. So yeah, I need a translator for that. So yeah,
So I would like to add something to that. So the concept of short forms in English are not the same in other languages. So like, I mean, it's not easy to have a short form in languages like Arabic or something. I mean, they use it. Also, this hashtag thing. In English, you have like lowercase and uppercase combination. You can actually have a single word, but you can define boundaries like, hey, this is Michael and Jackson, and J uppercase, so defines that. We don't have this luxury available in Urdu, Arabic, or other languages. So finding a nice hashtag is a problem in those languages, and that somehow defines how.
It's a whole different research. It's like a whole PhD by itself. So that's one of the angles.
So I have a question. So in a month or so, you'll be starting your job at Microsoft, right? And machine language, whatever, or something, right? So, so imagine they say, we want to come up with a service like Topsy, functionally like Topsy, right? Because that's something you relied on, and then they started changing in the middle instead. So, what could this service that you're assigned to build, what kinds of features would you build in? You have them start from the ground up. Now, assuming they say we don't want to get into the archiving game, right? So we're not going to run our own archive or anything like that, and we're not worried about pushing copies to archives per se, right? As far as the content, right? If you're working on something that is a Topsy competitor, what features do you build in to support the kind of analysis you're doing, the follow-on analysis? Anybody who comes in the next 5 years working on this thing, what do you build?
Okay, that's actually an awesome question. I would do a lot with this because here is the thing: building a service like Topsy on a Microsoft scale level, you have a lot of data and a lot of machining power, like computing power, and a lot of time, which is crucial in this, as Dr. Weigel here asked. If someone tweeted about something and I discovered it, and I have this URL, this link, I took a snapshot of it and realized that it actually changes. I can actually give this prediction while people are discovering tweets with a certain hashtag. Like for example, hashtag, I don't know, Michael Jackson, for example, when I'm presenting them, because this is actually in Topsy, you can search via hashtag, and it will give you all the tweets with external resources and such. If appended to each one of those, I'm saying, I can say the prediction of change of this, and when you are building a story, you can build a story from hashtags, and this is actually an application to Storyfy, for example. if you can create a story with the prediction of when the content is going to change or not, you can do a lot. This is a lot of power here.
As you detected change, what, you know, for defining an API for other people to build services, what do you do with this? So I'm using your, you know, new Microsoft /Thompson thing, and for this tweet and this URI, and we predicted that this URI has changed. So what do I do?
Okay, I can, okay,
Your Microsoft.
Microsoft, all right. I can actually utilize services that are available, like merge into archive today, for example. Take those snapshots and make them accessible with methods.
Microsoft might not want to get into the archiving.
No, what I'm saying is not really archiving, but rather caching. Okay? If I can predict that this specific resource is going to change by 60%, okay? I'm going to cache it just for a little while on my Microsoft servers, and keep it. If it was utilized or some other people shared this or looked it up, I can log all of that because I have the click logs and the search logs of everything. If this resource is deemed to be changing and it's discoverable and people search for it multiple times, I will keep a cached version of it, exactly like Google does it on their search engine on a regular basis. They keep a cached version. Why do they do that? For the exact same purpose. Because one of the purposes is to make it discoverable and a temporary version that they have of the website, and they update it and refresh it on a regular basis. That helps them in recrawling and for discovering new URLs, but in this case it will help us in
What about related things? If the thing is missing, eventually you're going to purge the cache, right? So what can you tell me for, you know, tweets that are 2-3 years old and the resources are missing?
With those tweets, okay, they can utilize my my replacement discovery thing, and given all the context that they have, they can index this with index the resources that appear based on the hashtags and the textual content that appeared along with it, and make a relationship between those. If you are talking about this specific event that happened this specific day, let's say Cinco de Mayo today, for example, a certain event happened, all right, and it disappeared, I have already indexed content with other shared resources. I can find it as a viable replacement. It's like a reverse search engine based on context from tweets. And I think that will be extremely powerful because it's written by authors and people, not discovered by machines. So, I believe so, yeah.
All right, any final questions?
Any other questions?
All right, we'll ask everybody to filter out while the committee
Thank you, everyone.
discusses.
Yeah, you close this.